This is also one of the easy Catriona puzzles, if there is such a thing. So we have to find the area of a ring which is formed from two concentric circles. Concentric means they have the same center. And so what you're going to have to do to find the area of a ring is take the area of the big circle, take the area of the little circle, and subtract. That's what we're going to have to do, where I introduced the usual variables. The smaller circle got little r, the bigger circle got capital R. And since things are given, what is given is 7 and 12. I don't even want to write down 12 because this is going to have to do with Pythagorean theorem. So where are the right angles? Well, this is called a chord, and the perpendicular bisector of any chord will contain the center of the circle. And so there is a right angle, and so this side here is really just 6, not 12. And there is one right triangle, and here is this other one. And so I'm a little worried because I don't want to introduce 3 variables, but I think we're going to need this side here. Let's see. So what do we know? Stating the Pythagorean theorem on the smaller right triangle, we get that a squared plus 6 squared equals little r squared. And then the bigger right triangle is going to state that a squared plus 13 squared equals to capital R squared. So it looks like, well, there are 2 options. We either have to sweat until we squeeze out one more equation from the situation, solve for A, and then solve for little r or capital R, or we can actually just look what we need. So when you feel like, okay, I started with what I have and I'm stumped, sort of try to look backwards from, okay, what do I need? And so what we need is this area. If you factor out pi, you will see that we just need r squared minus r squared. We do not need capital R alone. We do not need little r alone. We just need the difference of their squares. And that seems to be doable here. If we just subtract the second equation from the first one, which I'm going to do carefully. I'm just going to separate these and write down the opposite. Minus a squared minus 6 squared equals minus r squared. So now we add, a squared is dead, and all we left is 169 minus 36 equals r squared minus r squared. So that looks like we have 133, right? Yes, equals r squared minus r squared. So what we need is pi times 133. And then you could ask, okay, well, this worked, but could we find A and little r and capital R? And my suspicion is no. Because what if we start growing the little circle and the big circle? We could probably get a bigger circle and maybe closer to it a smaller circle where we could produce the same scenario. That's just kind of an instinct I have. I could be wrong. Maybe this, I am not sure if this data on its own uniquely determines the two circles. Luckily, we don't have to figure it out. So this is also typical to college algebra, that by the time you're done with the problem, you might have other interesting questions that you ask on your way to the answer. Thank you for watching.